First of all, we'll try to understand the difference between the resistance R and inductive reactance L omega and capacitive reactance 1 over C omega. Basically, like if I'm having DC source, okay, and if the DC source is variable, now I connected a resistance here. This is a DC source and I connected a resistance across the DC source, okay. Now the resistance, this element will resist or it will oppose to current, okay, the current I. If there will be less opposition, less resistance, then there will be more current. If it offers high opposition, high resistance, then there will be less current. Moreover, like the DC current, this is the DC source. Even if I connected some AC source, this is the AC source. AC means the voltage or the current, applied voltage, it is not constant. It is varying in magnitude and directions like this. Now again, the resistor will oppose to AC also. Okay, but the one thing is very interesting. You'll get some current I. It will oppose, even its opposition, you will get some current passing through the R. But the main important thing is, if this is a voltage, applied voltage, now that current will also dance in a same way exactly. Okay, the current will also dance in a same way, like this. Like crust and crust, trough and trough, the same. It is dancing in the same way. So we'll say that current and voltage, they are in the same phase when passing through the resistor, in the same phase, same dancing. Now I am coming, if I am having here, instead of resistor, I am having a coil. Okay? The coil also offers the opposition, but that opposition depends. Like in case of the resistor, like that in case of resistor, if R is constant, opposition is constant. Either you put R here across the DC source or across the AC source, that's no problem. But if we are connecting a coil across DC or across AC, then the coil behavior, coil opposition will be different for DC source and different for the AC source. How? Because coil opposition, let we call it XL equals to L omega. Omega is this frequency. Because DC is not having any frequency because it is constant, there is no frequency. If there is no frequency, XL equals to 0. Mean the coil will not oppose. There is no opposition. Okay, no resistance. I'll not say resistance, I will say reactance. Okay, because somebody will not confuse with this resistor, the resistance of this resistor. So I'll say the resistance of the coil like reactance. Reactance it means resistance, no problem. But we'll use the word reactance and inductive reactance. It is L omega, depends upon omega. The DC source is having no frequency, so it will not oppose. Okay? But coming here for the AC is having some frequency. Like I'm having AC of this type. I'm having the AC of this type. I'm having a frequency of this type. Because the opposition of the reactance is L omega, this omega is less, this omega is high, then omega is still very high. Omega 2 is greater than omega 1, greater than omega. So higher the frequency, the coil gives more opposition, more reactance, okay? And lesser the frequency, the coil will oppose less. So here the current flowing, AC current flowing, it becomes a function of the applied frequency when passing through the inductor or the coil. So very important. The reactance of the coil is not fixed. Of course, L is fixed, no problem, but also depend upon the applied frequency. If applied frequency is 0, there's no reactance. Now here one thing is more important. If the voltage is dancing like this, let the voltage is dancing like this, applied voltage having some frequency. Now when the current which is produced, while passing through the coil, it will not dance exactly according to the voltage. There will be it is dancing is different. How? When this is minimum, the current will be maximum. When it is maximum, the voltage is maximum, current will be minimum. The current which is flowing through the inductor, it will not dance accordingly as the voltage is dancing, and it dances like when voltage minimum, then current becomes maximum. When voltage maximum, current becomes minimum. So likewise, and we say the current here through the coil, it is in different phase to the applied voltage. Now coming to capacitor. If I am using a capacitor here, capacitor to DC, capacitor to AC. Now capacitor reactance is Xc equals to 1 over C omega. DC source having no frequency. No frequency means omega equals to 0. When omega equals to 0 means 1 upon 0. What is 1 upon 0? That is infinity. So Xc becomes infinite. Mean reactance, not resistance, reactance of the capacitor, which is Xc, it is infinite to the DC. That means DC cannot flow. DC current cannot flow through the capacitor. So there will be no DC current. Now if you connected the capacitor here, then the Xc equals to 1 over C omega. You are having different frequencies like this. Now here, more the frequency, less will be the reactance. Mean higher frequency can flow through the capacitor very easily. But difficult for less frequency, still more difficult for more less frequency to flow, to get through the capacitor. This frequency will find difficulty in crossing through the capacitor. So current of this frequency, it will find more difficulty. Current of this frequency will find some less difficulty, and still less. Higher the frequency, less the reactance. And again there is a, in the same way, the voltage and current will not dance accordingly here also. Okay? Again current becomes 90 degree out of phase to the voltage, with one difference, that now the capacitor voltage is along this side. This is the voltage across the capacitor. It differs again 90 degree to the voltage. Coil voltage also differs by 90 degree to the voltage. But coil voltage is leading by 90 degree, and capacitor voltage is lagging behind by 90 degree. Okay, of course, both are dancing out of phase with the voltage, and the phase difference is 90 degree, but one is leading and one is lagging behind. So if you are having the two resistors, R1 and R2, then I ask you, what is the total resistance? Your answer will be R1 plus R2. Now if I am having R and L omega in series, then I again put a question, what is the total reactance? You will say R plus L omega. But this is wrong. Why this is wrong? Because here it is concerned with the phase also. Okay, as it is concerned with the phase, so we put a J operator here because of the phase difference. Okay, now I can say the total reactance is R plus JL omega. J is operator like the iota operator. Okay, but you never say R plus L omega. You never say R plus omega. You say R plus JL omega. And when there are more than one element with the resistor, okay, having some reactance, then it is better to say impedance. This we call impedance of the circuit. It is R plus JL omega. Similarly, if you are having R and capacitor 1 over C omega, then what is the total reactance? You say your answer will be R plus 1 over C omega. Again, this is wrong. So because it is also concerned with the phase, you will say R plus 1 over JC omega. JC omega. Now J is in the denominator. Here J is in the numerator, because it also concerned with the phase. Okay, as you remember, the coil voltage was leading to the resistance voltage by pi by 2, and capacitor voltage was lagging behind. It was lagging behind to the resistor voltage by pi by 2. So that's why 1J it is the numerator, 1J it is the denominator. And capacitor voltage and in capacitor voltage and the inductor voltage, there is a phase difference of pi. Like this is ER, this is EL, this is EC. So this difference is of pi radian. Okay, that's why 1J in the numerator, 1J in the denominator. So it is okay for R plus 1 over JC omega. You say this is again impedance of the circuit. If you are having all the three elements, R, coil and a capacitor, Then what is the total impedance? R plus JL omega plus 1 over JC omega. Always remember to have the value of J with capacitor and the inductor, because to concern with the phase. Now lastly I am coming what we mean by, you are having some circuit, suppose, okay, this is my circuit, and to this circuit I connect, this is my circuit, and I may connect a fan here, I may connect a fan here, okay. Now when I connect a fan, it is running, okay, good. Then what we mean by load resistance here? You know, let my circuit is having 220 volt, and then this fan, it draws the current like 1 ampere. Now instead of this fan, if I am having a resistance, if instead of fan I am having a resistance of 220 ohm, then according to Ohm's law it will also draw a current 220 volt upon 220 ohm, and that becomes 1 ampere. Then I will say this 220 ohm, it is the load resistance here for the fan. The load resistance means the equivalent resistance which draws the same amount of current as your appliances which was drawing the current. And if you connect a heater here, load, suppose you connect a heater, okay, this is heater, it will also draw the current. Let it draw the current equals to 10 amperes, suppose, let. Then again my question, what is the load resistance of this heater? Very simple, you will find there is 220 volt and current is 10 ampere and resistance is equals to V upon I. Okay, what is voltage? 220. What is current? It is 10 ampere. So the resistance is 22 ohm. So I will say the load resistance in case of heater, it is 22 ohm. Any appliance you are connecting, it is sure that it will draw current from your circuit. When it draw current, it is equivalent to a resistor, and that resistor is called the load resistance. And moreover, if you are having some circuit like common emitter configuration, and you are connecting at the output, okay, like for example, you are having some circuit, common emitter configuration, this is a voltage, and you are connecting here another circuit, suppose. Okay, now this circuit, this second branch, it will draw current from here. If it draws the current, it behaves like a resistor. Then it behaves like a resistor, and that resistance will be called the load resistance. So that load means like a current, anything that loads the circuit is that draw the current from the circuit. The thing that draw current can be next stage, amplifier, input section, a motor, a speaker, inductor, capacitor, anything. Okay, to represent all or any of these conditions, we can use a resistor which draw an equivalent current. This resistor is aptly named as the load resistor. Whatever you connect to the circuit, no problem, like TV, heater, speaker, mobile phone, charging, all are the loads. In the circuit, all loads are shown as the resistors. When load is not connecting, there is no current flow to the circuit. When there is no load is connecting here, then no current will flow. Then there will be no current. A load is anything which carries output current from a circuit or the device, okay? And you may put a question, can resistor itself can be a load side? Okay, a resistor itself can be a load, but what is the use of it? No use. Like this is your voltage source and this is your some circuit. You are not connecting any appliances, but simply a resistor. You are connecting simple a resistor and you are calling it load resistor. This is not appliance, a simple a resistor, and you are calling it RL. Then what the use of RL is? Nothing. Okay, this is a functionless kind of load. The resistor does not do anything, okay, other than to only to limit the current flow. It will oppose the current, it limits the current, thus it is. But it is, functionless kind of resistors. While doing that, it creates an amount of heat. It will create amount of heat proportional to the current and the resistance. In most cases, this is simply the waste heat, okay, requiring some material or some device to remove the heat and transfer it away from the resistors. Okay, I think it is clear to you what we mean by the load resistance and how the load resistance is different from the real resistor. Load resistance is never a real resistor. It may be real resistor, but only in that case it will produce the heat. Otherwise, it will be the appliances there, and that appliances will draw current, and with equivalent current can be drawn by a resistor, and that resistor is named as the load resistor here. Okay, thank you very much. My name is Mahajan. My phone number, country code +91, phone number 9888 169 226. You can contact me on WhatsApp for any difficulty in electronics. Okay, thank you.